move on from that. All right, so transformations of functions. We are going to talk about review. So let's start with what we should know. Transformations are going to happen throughout the course. So we're going to talk about periodically how every function is shifting left, right, up, and down. I don't know how to explain it, but it's just overlapping. So we're not going to dive super deep into it because you've already learned about it in the past for each function. So in Algebra 2, we did transformations for every single family function, right? We did transformations of quadratics, transformations of absolute, transformation of rationals, transformations of exponentials, transformations of logs. Is going to be built on here. It's just going to be in a different format, okay? So in Algebra 2, you guys learned about vertical, horizontal translation, and vertical and horizontal stretch and compress, right? Now, in pre-cal, we no longer say stretch and compress. We say dilation, okay? And that's because a dilation implies that something is either stretching or compressing. Does that make sense? It means the same thing. We just no longer say stretch and compress. Yes? That's the only difference from transformations from last year to transformations this year is that change in verbiage. Got it? All right, so vertical translation. In order for something to be moved vertically, we are adding our k value. Do you remember that? It's on the outside. That means I'm taking my y value, my current y value, and I'm either adding or subtracting to it, right? And that's what's going to cause it to go up and down, right? So here, f of x minus 2 caused it to shift down 2 because I took all the y values and subtracted 2 from them, correct? Yes? All right, next, horizontal translation. Remember, so I have no clue why AP Pre-Cal has done that. So you remember how I've always taught you that X's are liars, right? However, it's crazy. And AP Pre-Cal, they just want us to take away the fact that it's X minus and put X plus H, okay? So notice here that it says X plus H, but X plus H implies that this is a negative H. So still, X is a liar. It just no longer starts off as a minus. Does that make sense? Yeah. Okay. So even though it says X plus H, you are still translating to the left. Yes. If it said X minus H, then it's going to go to the right. Yeah. So for example here, f of x is our bold, right? And we're saying that we're going to do x plus h, x plus 2, which is going to be our g. Notice that it shifted the bold to the left, okay? So we're not supposed to emphasize that x's are liars. However, x's are still liars, okay? This is not telling you to go to the right. It's telling you to go to the left. Yes. Yes. Yeah. It was written at the bottom of our title. Right. Right here. It said review. Crazy. It's crazy. I did. All right. Now, vertical dilation. Vertical dilation now takes place of vertical stretch and shrink or vertical compression, right? We just call it a dilation. Okay. Vertical dilation means that how is your function changing across the y-axis? Is it stretching or is it being compressed? Okay. If you remember from Algebra 2, that's when I kind of use the analogy of working out, right? The more you work out, the thinner you get, right? The less you work out, the wider those hips go. That makes it compressed. Okay. Essentially, what's happening is that to all of your y values, you are multiplying by a value, correct? So with here, you are multiplying by a value, okay? And we call that a dilation. It is the absolute value because the negative has a whole different meaning. Does that make sense? We're not talking about whether it's positive or negative. We're talking about what is that value and what is that value doing, okay? Horizontal dilation. Horizontal dilation, last year I talked about the accordion, right? What's the thing called? Accordion? Yeah. Remember I talked about the accordion? The more pressure I apply, that's me compressing it, right? When I release pressure, that's me letting it go, right? That's the stretch, right? That's because our x's are a liar. It looks like I'm multiplying, right, to all of my x's, but essentially you are dividing by every x. You're dividing every x by b because x's are still what? Liars. They lie, okay? Addition is subtraction when it comes to an x. Multiplication is division when it comes to an x. Yes. It does.
Oh, okay.
Yeah. Yeah. Yes. So if you are, I haven't gotten to the negative part yet. I was just talking about the dilating part. All right. So dilations again for our x's, we are dilated. Um, if I'm dilating on the x-axis, it's going to be the opposite of what's happening to my x's. I'm not multiplying them. I am dividing. The b is being divided. Okay. So if we had it all put together, hopefully you guys remember this transformation rule. So all put together, do we remember seeing if I had, oh, or it won't let me write. Let's try again. Ah, that's an ugly A.
Oh.
Okay, there we go. Let's try. So your A can be positive or negative. That's on the outside. On the inside, that's going to be your B times your X plus your H and then your K. Yeah, I should have wrote it across here. Let me write it here. So G of X can equal plus or minus your A, your F times B of X plus H plus your K. You can have all these transformation values in place. Sorry, and B can be also positive or negative. F is just any function. It's F of all of this transformation. So if you look right here, notice it says that G of X is the transform. F of X is your original that you're manipulating. Okay, it can be anything. Okay, if you have a negative A, that's a reflection over the x-axis. So if you have a negative A, it's a reflection over the x-axis. If you have a negative B, it's going to be a reflection over the y-axis. So it's always the opposite. Okay. And that makes sense because if I'm changing my y values, if I'm making my y's negative, they're going to flip over the x-axis, right? If I'm changing my x values, they're going to flip over the y-axis, right?
Oh.
Yes. Do we see that connection? Okay. Is all of this coming back? Yes. Okay. All right. Nothing's changed. The only main change is dilation. Got it? We no longer are going to say stretch or compression. We'll just say a vertical dilation by 2. Okay. A horizontal dilation by 1/2. Okay. We no longer have to say stretch or compress. Got it? All right. So, few important things that I want to make sure we're aware of. Any transformation that affects the x values will occur inside the parentheses with the x, right? If I'm inside with x, that's who I'm impacting, okay? Any transformations that affect the x values will do the opposite of what it looks like because x's are liars. It will do the opposite. If it says plus b, that means I'm actually subtracting b, right? If it says, I'm sorry, plus h, I'm actually subtracting h. If it says times b, I'm actually dividing b. It's going to always do the opposite, okay? Any transformations that affect the y values are outside of your parentheses. That's your a and your k. They are away from the x, right? They're outside of your parentheses, okay? And they do exactly what they say they're going to do because why lie? You know, there's a reason. Why? Why? Okay? You don't lie. You just do it. Your a and your k are just going to be what they are. If a is 2, I'm multiplying by 2. If k is minus 2, I'm going down 2. Make sense? Yes? Those are big, big things. Okay? Again, did we already know this? Yes. All right. Now let's take this and look at it from a pre-cal standpoint. All right. A lot of times in Algebra 2, we were looking at a graph or a function and saying, how did I get from here to here, right? From point A to point B, or how can I get from this function, or what does this transformation mean is going to happen, correct? All right. It's a little different here. So it says, let n be a function that is a transformation of the function m, such that negative 4m to x. Okay. So m is actually a function. N of x is the transformation. So let's, n of x is your transformation. Okay? M of x is your original. This is your original function. So what it's asking you, what do the numbers mean that I've now added to the original? So what are the numbers that I now added to the original? I now added -4. What variable does -4 represent? A, B, H, or K? A. -4 represents A. Make sense? Okay. The next number that I added to the original is 2. What variable does 2 represent? 2 is your B. 2 is your B. Once you've identified what they are, you should be able to say what the transformation is. Okay. All right. So if I'm describing A, that means that from here, I know that this means that M of X is what? I have, what does the negative tell me? What does the negative on my A tell me? It's going to reflect. It's a reflection across what though? A reflection across the x-axis. So I know from here that it is a reflection, reflected across x-axis. Okay. And what does the 4 tell me? So what is that called? Let's go back and look. If I'm multiple, it's dilated. It's a dilation. And what kind of a vertical dilation? So the 4, so it's reflected across the x-axis, and there's a vertical dilation by 4 of 4. Of or by. I don't know if I'm supposed to. I'm gonna say of. Sounds right in my mind. I think I skipped example number 1, didn't I? How did I get to 2? You don't know how to count. Are you serious? No. That's funny. Just checking, making sure. Just making sure you knew what we were doing. All right. Dilation of 4, dilation by a factor of 4. I don't know. By a factor? Okay, we'll figure out that later. Anyways, 2. What is the 2 telling me? What is 2 telling me? Is it negative or positive? So it's not a reflection. But what? It's a horizontal dilation. So we have a horizontal dilation by a factor of 1/2 because our x's are liars. It's actually not 2. It is 1/2. So I'm not going to multiply each by 2. I'm actually going to divide each x by 2. You reciprocate. Yes. I really feel like I need to give y'all an example number 1. No, so that we can stay numbered correctly. You have room at the bottom of your page, don't you? In the front? No, we don't. At the bottom underneath the box? Y'all are liars. I wrote notes on them.
I did too. I wrote D of X equals
Underneath here? You all did? We're gonna squeeze. Oh, we're gonna do it. Oh, you can't even do it. So that my numbering makes sense. Example number 1. Example number 1 underneath at the bottom of your front page. Here we go. If I gave you g of x equals 2 f of x minus 3 plus 1, what transformations took place? Okay. So it's we got to use the correct term. So we have a vertical translation. There we go. So we have translated up 1. Then what else? Horizontal translation. We went right 3. And then what else happened? We don't say stretch. There we go. Vertical or horizontal? Vertical.
But 2.
Yes. All right, now we have a number 1. Okay. What? It wasn't a terrible number 1. Honestly, it was not. You wanted to complain. All right. Good. All right. Now we're on to 3. So we have 1, 2. It does not. I was like, did I mess up again? All right. You tried to tell me that there wasn't a 3 and it went to 4. I was like, no. All right. So we're all good now. So the graph is, yeah. All right. So here we have the graph of y equals f of x consisting of 2 line segments. Nope, not that one. Yeah. Segments, and we're going to draw the other one. Of a semicircle is shown from -3. X is greater than or equal to -3, but less than or equal to U2. 5. Sketch the graph G on the same axis showing the following transformation. So we have G of X equals F of X plus 3 minus 4. So how am I going to create my second graph? What am I doing? I know, but we have G of X. We just practiced on example number 1. What are we doing? So what are our translations?
Vertical.
So we have a horizontal shift, and we're going to go left 3. And what's the vertical? And what does that tell us? We're going where?
Yeah.
So we have a vertical shift down 4. Make sense? All right. So we're going to take the points, some key points, and we're going to just move those key points. Does that make sense? So I'm going to move -3, 1, 0, at 0. I'm going to move at 3, and I'm going to move at 5, following the rules that we just said, right? Probably also need to take this little guy with me so I can do it correctly as possible. Okay, so I need to go here. I need to go left 3 and down 4. Is that what we said? So 1, 2, 3, 1, 2, 3, 4. So here's their new home. Agree? Yes. Again, we're going to go 1, 2, 3, 1, 2, 3, 4. Here's his new home. I do it in the end. We're going to go to the hump. I'm going to say the hump is on a halfway mark. Is that cool? So we're going to be on a half. So we're going to go 1, 2, 3, then 1, 2, 3, 4. Okay. So there's my hump. It thinks I want to do more than that. Again, I'm going to go 1, 2, 3, 1, 2, 3, 4. And then our last one, 1, 2, 3, 1, 2, 3, 4. And now I'm going to connect. That's the straightest line you've ever seen. I know. Look at that curvaceousness right there. And boom. Thank you. I tried. Oh. You sound like a hater. All right. They look identical. Do it. Yeah. All right. Yes. Are we good graphically?
Yeah.
If you're not, where are we stuck at? I counted left 3 and down 4 every point. All right, the next one we're going to model using a table to make the transformation. Okay, are we good with counting spots on the graph? All right, so now we're going to talk about how to do without counting spaces and creating new points. Okay, all right, so here we have the graph of y equals h of x has a hole at x equals 4. Cool. And consists of 3 linear segments. Okay, sketch a graph of k on the same axis above where k of x equals negative h 2 of x plus 1. All right.
Listen.
So, and to do this by table, you would choose your points that are already on your table, on your graph. Okay, so I'm going to choose the points that are currently there. So currently we are at, and this is called h of x, right? So we're currently at -4, -3. Is that correct? We're at -2, 1. We're at 0, -2. We're at 2, 0. There's a hole in my graph. There's a hole in my graph at 4, 2. I'm going to mark this as an H. And then there's a value at 4, -1. And then last but not least, we're where? 6, 4. See, senorita, the pass is over there. Okay, so this transformation is telling me how my x's and my y's are being impacted, correct? So transformation we have is -h times 2x plus 1. Okay, the negative, is that impacting my y's or my x's? Outside of the parentheses, anything outside of the is y. And so is so this is going to be an impact on y, and this is going to be an impact on my y's, right? So that means all of my y, so my old h of x, to each one of those y values, I'm going to have to multiply by a negative and then add 1. Does that make sense? So each one of my y values is going to be multiplied by a negative. I'm going to have to add 1. Okay, what's happening to my x values? X's are liars. I'm dividing by 2. So each x value is going to be divided by 2, and that's going to be my new table. Okay? So coming over here, we're going to have our new x's, and this is going to be for our table k of x. Okay? So each x is being divided by 2. What is -4 divided by 2? -2. -3. And to each one of my y's, what am I doing? I'm changing its sign and adding 1, right? So -3 becomes 3, and 3 plus 1 is 4. Do it with me? We identify what our transformation rules are, right? And now we're applying those transformation rules to our table. So the first rule, it says that your x's are all being divided by 2. So I can divide all of my x's by 2. Right? All x's have now been divided by 2. And then now we're doing our y's, right? So our y's are every y is changing sign and adding 1. Agree? Change the sign and add 1. Change the sign and add 1. So 1 is going to become what? 0, because it becomes negative. -1 plus 1 is 0. -2 becomes a +2, and 2 plus 1 is 3. 0 is still 0, and 0 plus 1 is 1. 2 becomes -2, and -2 plus 1 is -1. And again, this is my what? Oh. And this is just a point. -1 becomes a 1, and 1 plus 1 is 2. And then 4 becomes a, and -4 plus 1 is -3. So these are my new points for my, because there's a hole. There's a point in a hole. It just means that when I graph it, I have to make sure I keep it a hole. Yep. No, I didn't. My hole. And then this is the point. Yeah, because it follows the transformation. is no longer there. My hole is going to move with my graph
So why is one of the two things?
because I have a hole in a point. All right, so -2, 4. So I'm going to go to -2, go up to 4. So -2, and we're at 4. Then I have -1, and we're at 0. I have 0, and we're at 3, 1, 1. Right? And then we're at 2, -1. And at 2, -1 is actually a what? A hole. So let me make it real obvious. And then at 2, we have a point at 2, 2. It's just a lonely little point that's chilling up here. And then at 3, we're at 3, -3. So now I'm going to connect. I go, pew, straight, beautiful straight line. I know. Pew. Then pew. And pew. Oh, I skipped a point. And you weren't going to tell me. I just left the 3 up there all by its lonesome. Pew. Pew. And there's my transformation. It's right there. It's just a point.
Oh, it's just
It was just a point.
It's just a random.
It's just a random point to make this continuous graph.
Oh, okay, I see how it is.
So the whole makes 2 not defined, right? But at 2, 2, that makes it defined. Yes, because that's where the whole.
So, we don't draw draw the point there.
I did my point and I did my hole. Do we see them? Did I not do them?
I understood it now. It's like a wormhole.
Okay. All right. How do we feel? We survived? Huh? It's really boring. I'm sorry. Actually, I can understand it. Maybe it's because I'm not over there. Hey, that's an empty desk. All right. So now the next thing is how does changing how transformation affects your domain? Okay. So the domain from example number 3 is negative x is greater than or equal to -3, but less than or equal to 5. And the range is y is greater than or equal to 1, but less than or equal to 3. Okay. And the domain and range of g were what? Were g of x equals 2, f times x plus 3 minus 4. So if I applied this transformation, which we did, right? Didn't we do this? Oh, we didn't do it with the 2. We only did it with x plus 3 minus 4. That's cool. Just stretching it. Just going to stretch it out a little bit. All right. So going back to our example number, can I go back to 3? Is that okay? So because it says go back and look at example number 3. So in example number 3, we have this graph, correct? With the horizontal line, the linear, and the curve, correct? On the semicircle. And it said that your domain is obviously what it is. Are we all comfortable reading the domain and the range of this function? Yes, we are. I believe in you. You're great. So based off the domain here, it wants to know what would be our new domain if we made these transformations. So if we made the transformation that we already made, but now change it to 2. That 2 in front is impacting what? X's or Y's? The 2 in the front is going to impact the X's or the Y. It's going to impact the Y's. So right now we don't have a 2 impacting our Y's, right? But if I was to take all of my Y values, what would I be doing to them based on that 2? It's positive 2. It's going to vertical dilation, right? So I'm going to stretch. Is that going to change my domain or is it just going to change my range? Did I touch X? No. It's not going to touch my X. So if we go back here, we're going to sketch it on. If you come back to your example 3, I'm going to sketch it on here for you. So I'm not changing my x's. I'm just changing the y's because it says now I have a vertical dilation by a factor of 2. So each y value is going to be multiplied by 2. Does that make sense? So currently, this is at -1. -1 times 2 puts me where? At -2. So this value would come here. Does that make sense? -3 times 2 puts me where? -6 would come here. This is like 1.5. Yeah. -1.5 times 2 puts us at 3, at -3. No, we're number 5 said to have a 2 in front now. So 2 on number 5, it says that we're now going to dilate this, right? And it asks what would be our new domain. Or would our domain change or just our range? Okay, here we're at -3. -3 times 2 is, so it's going to come down here. They're all this, it's a +2. So we're multiplying everything by +2. And then again, -3 times 2 is going to drop it down to -6. So looking at this, did it stretch vertically? Yes. Did it have any impact on my domain? No. So a vertical dilation has 0 impact on my domain. Does that make sense? Okay. The vertical dilation had 0 impact on my domain. However, it did change my range. So number 5, it says where g of x is 2, this was our new transformation of x plus 3 minus 4. What's the domain and range of what we just did? Well, our domain was what? It was the same as our original transformation, which is from where to where? What's the smallest x value I go to? Smallest x value? -6 to my largest x value, to 2. So my domain is okay. Or I can write it in interval notation, -6, comma 2. Yes? And what is my range now, though? My range didn't change. So what is the new range of my transform function? So from bottom, what's my lowest? And what's my highest? -2. So my range is now from -6 less than or equal to y less than or equal to -2. And I can write it also as -6, comma, -2. Notice that when I write it in interval notation, I use brackets. How do you feel? All right. Now it's table time. Okay. So on the table, from the table perspective, your h of x. I'll come back to that. I know what I did wrong. Nothing. Conversation with myself. Uh, your h of x is your transform. So p of x is your original, and h of x is how you're going to transform p of x, right? So 2p of x, what are we doing? What variables are we given? We're given our a, which is 3. We're given our b, which is 2. And we're given our k, which is -1. Okay, you have to identify what each one of them is going to impact. Your a is going to impact your y. Your b is going to impact your x, and your k is going to also impact your y. Make sense? Okay. So to each one of your b values, to each one of your x values, what are you doing? Remember, x's are liars. It's dividing. It is not multiplying by 2. It is going to be dividing. So to each one of these, I am dividing by 2. So my new x's would be what? Then make sense? Okay, on your p of x, your y's now, what's happening to them? And then subtract 1. I have to multiply each one by 3 and subtract 1. So my h of x is going to be what? So 3 minus 1 is 2. Negative 3 minus 1 is 0 minus 1 is negative 1. 3 times 3 is 9 minus 1 is, and then 20. So now you're answering. So h of negative 1. To the y values, these are your a and your k. So your a says you're multiplying by 3, and your k says you're subtracting 1. So to each one of our y values, we multiply by 3 and we subtracting 1. Agree? All right. So now if they can ask me anything, because my table's ready to go, right? So if I ask you what is h of negative 1, what are you going to tell me? 2. H is basically your y. Your x is on the inside. So if I ask you for h of 2, you would say what? 8. Again, your x is on the inside. There you go.
So hard.
It was terrible. Cruel punishment. The what? The 2 and the 8. So we made our table, right? And so we're looking at the red values from the table. So it's saying that when your red number is negative 1, what do you get? 2. When your red number is 2, what do you get? When your red number is 3, what do you get? Yeah. This is red. All right. How do we feel about answering questions from the new created table? Yeah? Still doable? On your note card? Mm. All right. The function g is constructed by applying 3 transformations, okay, of the graph. We want a horizontal dilation by a factor of 3. We want a vertical dilation by a factor of 4, and a vertical translation by negative 7 units. What is our equation? All right. So horizontal dilation, what variable is that? Our b. And if I want it by a factor of 3, what must be true? It has to be the reciprocal of that. If I want it to be by a factor of 3, that means b has to be 1/3. Okay. If I want a vertical dilation by a factor of 4, what variable is that? A equals what? Did it tell me to reflect? No. It just says by a factor of 4. And if I want a vertical translation by negative 7, what variable is that? It's our what? It's our k. I don't know. I'm ignoring that. In our notes, we wrote K. So now we're going to put it together and write our g of x. So our equation is g of x equals, what's A? 4 f of, what's B?
1/3.
1/3. It's 1/3. Okay.
Oh, no.
Oh. Minus 7. That's all it was asking you. Yay? How do we feel? Good? Doable? All right. What do you mean?
Oh, watch this be like 500 president.
Oh my gosh.
It's gonna get harder and harder.
I feel like I would just want to complain and lie. All right. Here we go. So the table above gives values for the function h of x. H as selected values of x. Let k of x equals a times h times b of x plus c, where a, b, and c are positive constants. So they're positive. In the xy plane, the graph of k is constructed by applying 3 transformations. Here are your transformations. Write the function. Yeah. Your turn. Really? Go back and look at example number 7.
You're gonna go over it.
Yes, C is K. Are you going to try? Can you try first? Your head down is not you try. I didn't think it.
I don't think Alberto's here.
You don't think Albert's here?
Yeah, Alberto, that boy.
If you have a figment of my imagination, and I'm pretty sure it's like,
He lives within our hearts.
was that why?
Yeah.
Okay.
It's sad, but
Not a good sign, let's see.
If it's horizontal, dilation is still horizontal.
I see something.
Beyonce party.
Instructed to Beyonce.
Yeah, okay.
Hold on. I think that,
Yeah.
cause we like so Friday, wait.
No, it's just not a reciprocal.
Don't see you. You're so much.
All right.
Wait, I'm not ready.
Yeah.
I just said all right. That's it.
Oh.
Saying that I took attendance.
I know, but all right.
All right.
Like, oh, it's time to move.
No, it's all right. I took attendance before they called me.
No.
Yes.
If it's a vertical dilation, it's supposed to be, right?
Mhm.
How do you,
Vertical doesn't lie.
which one is B, vertical or horizontal?
What did we say? Horizontal is always your B.
There's a horizontal dilation of 1/2. Sure. B equals 2.
Reciprocal. Reciprocal. Reciprocal.
That's just the x times.
Vertical translation. Is X? Wait, what would vertical translation be, K?
What? Vertical translation would be your K. In this case, the C value. Randy, you ready to tell me my equation? I believe in you. So K of X. This function is called K of X. Okay, you're right. What? Tell me what K of X equals.
Was 4F.
Oh. Right, yeah.
What's my A?
X.
Mm-hmm. This,
I have it on my paper.
Yeah.
what function am I transforming?
Let me rewrite this for you.
There we go.
Oh, it's good. I feel accomplished because I actually.
All right. So, now we're going to talk about how to evaluate from here. So if it gives me a value, so it says k of -6, right? That means that we can evaluate k of -6. Where -6 goes means that it's now replacing your what? Your x. So it becomes 3h2 times -6 plus 1. What is 2 times -6? 12. So we have 3, and we're looking for h of 12. -12 is the value plus 1. Is the value for h of -12 on our table? Yes. What is the value of h of -12? What's its output? So where h of -12 is, I'm now going to write a 1. So our final answer would be 4. Okay. Yeah. So if the value wasn't on our table, then we would have no solution because we don't have enough information to build on. Does that make sense? But because h of -12 wasn't on the provided table for us, yes. So therefore we can follow through and finish out the problem.
What do we do?
You transform your table. Then you got 2. Or then you get 4. What did you get? What's 3 times 1? What's 3 times 1? What's 3 times 1?
And then
Oh, okay. Is it 3? Oh, okay. And 3 plus 1 is 4, Emiliano. 4. I knew it all along. I knew you had it in you. All right. Emiliano did what we did where we transformed the table. This is showing you that you don't have to transform the table unless you have multiple ones to solve, right? If I'm just solving one single one, I can just plug in that value and evaluate. Yes.
How do you go up by 1 unit?
Because it just says by 1 unit. It didn't say by a negative unit. So you assume it's 1 unit. You assume it's positive because it's not stated negative. Okay. Still good? All right. Last one. All right. So we have P of X. What's wrong? Oh, sorry, Emiliano.
Your number, what number is it?
I thought we could just count and keep things in order, but apparently
Oh, is this still the same?
we're still in the same 6 weeks. All right, here we go. So we have the function P is given as 3x minus 2, which is just a what equation? Not regular. What kind of equation is this? Say it louder. Heard someone? Original? No, linear, guys. It's linear. Mx plus b. All right. The graph of R is the image of the graph of P after a horizontal translation of 4 to the graph of P. Okay. So we have R of X equals AX plus B. Find the values of A and B. Okay. So we want to horizontally translate. Okay. If we're horizontally translating, that means that we have a H value, correct? Does that make sense? So what this is saying that R of X equals P X, and I'm going to the right. So it's going to be -4. That's what this is telling us. It has a horizontal translation of 4. Is there anything else happening to P of X? No. So to find its new, what is R of X? We now are going to follow through with the function notation. So R of X equals, and this means that in P of X, wherever X is, I'm replacing it with X minus 4. Does that make sense? So this becomes 3 times X minus 4 minus 2.
So x minus 4 takes place of x.
Yes. And now we just got to clean it up. So R of X equals, distribute. We get 3X minus 12 minus 2, which ends up becoming minus 14. So we have 3X minus 14. Okay. From there, it wants us to state our A and our B. So what is our slope and our y-intercept? Our slope is what? 3, and our y-intercept is negative 14. And that is our final tab on transformations. Yes? All right. Your teacher has a error she made, and I wanted to wait to the very end to say I made an error. What? I know, I'm horrible. I made an error on example number 5, and I didn't realize it until after we already had did it. Okay. On example number 5, because of that 2, we can't translate first. So before we went down, we should have multiplied. Okay. And so our range is incorrect. All right. Does that make sense? Because I should have followed PEMDAS. I should have multiplied and then shift down, but I didn't do that. So this is not correct. I'm human. I apologize. I haven't finished my coffee. Okay. Me taking responsibility. Duh. I took responsibility. Okay. So the shortcut here to finding your range is just apply the manipulation to your old range. Okay. So the range of the original is from 1 to 3. However, to each one of my y values, I have to multiply by 2, then subtract 4. So for my new range, so the range of g of x, it would be 2 times 1 minus 4 is less than or equal to y, which is less than or equal to 2 times 3 minus 4. So what is my actual range? What's 2 minus 4? Negative 2. What's 2 times 3? 6 minus 4? 2. So that is my actual range of that transformation. I apologize. I was like, wait, hold on. We'll come back. All right. We didn't even need the graph. We just had to manipulate the given range. They gave us our range. Huh? You could still put in interval notation. And interval notation would be negative 2, 2, 2.
What did your graph look like?
Ignore the graph.
Oh,
Graph is irrelevant, is what I'm telling you. You have a pencil though. All right. Did we understand my correction? All right.
Wait, no.
Yes, Max. I'm not taking it away. Yes.